Okay. Good evening, everyone. Welcome back to the second week of TA live sessions for AI search methods for problem solving. Before we get started, can any one of you confirm if I am audible and if my screen is clearly visible?
Yes, sir,
Yes,
you're
sir.
audible.
Okay, thanks for confirming. So, yeah, welcome all. So, this week we'll be going to discuss some questions from week 2 of the course, which will mostly deal with simple search methods like DFS and BFS. Yeah, and so, yeah, without any further ado, let's get started. And I hope the problem with the number of people in the meeting does not sustain in this week and the coming weeks. In any case, the recordings are available to everyone after the session ends. So yeah, that is an easy solution. Okay. So to address a question in the chat, Shreyas, if you have some doubts regarding the course material, I can help with that. But if you have doubts that are related to the logistics of the exam, then I'm afraid I'm not the right person to ask that question. It will be better if you direct your question to the discussion forum of the course, where someone from the NPTEL team or Bhaskaran sir can answer your queries. Okay. Okay. So let's get started. Just to save bandwidth, I'll switch off my video, but let me know if that seems okay. Okay, so let's get started with the questions for today. So this is the space, the state space or the graph that we will be using for a lot of questions today. Okay. You are given the graphical representation as well as the state table representation over here on the left, and in all the cases the node S will be the start node or the start state, and your node G will be the goal state. Okay, so you have to find ways to go from S to G via different algorithms. Okay, that is the idea that we have to solve. And then on the table on the left basically represents, given that you are at a certain node, let's say you're at S, what are the nodes that you can go to. Okay, so so this move gen of X basically tells us which are the nodes that you can go to from S. So they include C, A and B, right, because they are the nodes that are connected to S, connected immediately to S. Okay, similarly for A it is B, E, D and S. Okay, so I'll leave this diagram here on for a couple of seconds so that you can familiarize yourself with it, and then we will move on to the questions for today. Okay, so I hope that was clear. If there are any doubts in the diagram or the move gen function, please feel free to ask me. For now, let's move on to the questions. So the first question is, identify the DFS search tree. Okay, DFS meaning depth first search, and what we have to do is we have to choose the correct option amongst these four different trees given over here. That will tell us which is the search tree that will be followed if we choose to use the depth first search algorithm starting from node S, and our goal is to reach node G. So I'll let you think about it for a couple of minutes before we go deeper into the solution, but I will encourage you to try it out yourself, and then we can see how we arrive at the solution. So Ravi is asking a question that directions are not given in this figure. That's fine, Ravi. Whether there is direction given or not, you can still apply the depth first search. Yeah, when there is direction given, it just means that you can only go from a node to another node in a certain direction, not the way back. In that case, that will be reflected in the move gen function. Okay, in this case, you can go from S to A and A to S, for example. If there is direction given, let's say from S to A, you can only go from S to A and not from A to S. So depending on the problem that is given to you, you'll have to modify your move gen accordingly or plan your depth first accordingly. Okay, but that's a fair point, and thanks for raising that. Okay, and one more clarification. So let's say in case we are at a juncture where given the node that you are at, you can go to multiple nodes. For example, if you are at S, you can go to 3 different nodes, right? C, A and B. Then you have to choose one of them to explore further, right? In that case, unless specifically mentioned to follow a certain way, you can assume that you can follow the order in which the nodes are mentioned in the move gen function. For example, here when you are at node S, the move gen function tells us from S you can go to C, A or B. So if you have an option to go to either C, A or B from S, you will choose to go to C first, or you will choose to explore C first. Okay, and then you can go to A and then B. If the depth that you reach via C does not give you the final goal node, then you can retrace back and try to explore the node A. Okay, so that's the extra piece of information. Okay, so does that give you any hint of which of these trees could be correct? We told that from S, the first node that we can go to or explore would be C, right? So does that eliminate tree 3 from our options? Sure, Dhruv. Let me switch to my whiteboard so that I can better explain it. So let's say that we are at S. Okay, this is too thick. Shubham, maybe you can mute yourself if you don't have a question. That will help us. Yeah, thanks for that. Yeah, I think this is better. Okay, so let's say you are at node S. Okay, and from there you can go to C, A or B. Okay, now you have to choose which way to go, right? You are at this point, you can go to either of these 3 nodes. Unless you are explicitly told which way to go to, you could have randomly chosen one of the nodes to try and explore, right? But another criteria or restriction that you have been given in this question, in this specific question, note that this may not hold for all questions that you will encounter in the course. If you are not if you're given some other criteria, you should follow that. Okay, but for now you are told that you have to follow the order that is given in the move gen function over here. Here you are told that from S you can go to C, A and B. So C has preference 1, A has preference 2 and B has preference 3. That's why you will go from S to C and then you will explore where to go from C. Okay, that is how you will structure your depth first search. And if we go back to the trees that were given to us, okay, now tree 1, tree 2 and tree 1, tree 2 and tree 4. all these three trees, after S, the first node that they explore is node C, right? Because that is the leftmost child of S. So that seems to follow the restrictions that we had imposed on ourselves, whereas in tree 3 we go from S to A first, which is contradicting the restriction that we imposed, or the question imposed on us. So we can straight away say that tree 3 is not a correct option. Is that clear? Okay, great. Thanks for confirming, Shreyas. So now we are left with tree 1, tree 2 and tree 3. Okay, so let's explore further which of these could be the correct options, right? Okay, so we were at S, right? We went to C. Now from C we can go to F, B and S, right? We won't go back to S, right? Because as per DFS we have already explored S. S is now in our closed list. Okay, so we can go to either B or F, right? And based on the move gen function, sorry, I was not sharing the screen. So we are at C, right? We can go to either F, B or S, right? We won't go back to S because S is already explored, right? It's in the closed list. So which of B or F do you think we will go to based on the move gen function?
F.
F, right? Because it appears first in the move gen function. So from C we will go to F. Then from F, where will we go?
H.
Are you sure? See, from F we can go to
Sorry.
these
D.
solutions, right? And B is something that is still unexplored, right?
E.
You go, D. You can go for D.
No, we should go for B, right? Because if you look at the open list at this state, when we were exploring C, we added B to the open list, right? And when we were at F, B is still in the open list, right? And that's why B would be explored first, and then E would be explored in that preference, right? So from F we will go to B. Do you agree with me? Any confusion over here?
Yeah, okay, it's clear.
Oh wait, I think I am wrong. Sorry for that. So one of your colleagues had said that we will explore E from F, and I think he was correct. Sorry for my error. So I think in these cases it's better to maintain the open list and the closed list, right? That is what caused the confusion over here. So do any of you remember what is the data structure that we use in case of DFS?
Stack.
Stack, that's right. So using a stack is what makes us go from F to E rather than B. Okay, let us maintain an open and a closed list on the side. Okay, please excuse my handwriting. Okay, let's start from the beginning. Okay, initially we were at S. Okay, in this case closed list is empty, right? From S we went to when we were exploring S, we added the following nodes to our open list. Okay, this is a stack, right? So this is the front of the stack. Okay, so elements will get popped out from this end. And at this point we have explored S, so S is in our closed list. Okay, next we will explore C. When we explore C, C will be added to our closed list, right? But there are things that will be added to our open list, right? From C we could go to F, B or S. Now S is already in the closed list, B is already in the open list, so we don't need to add it again. So the only thing that will get added is F, right? So F will be added at the top of the stack, right? Because that's the only place where we can add things. Are you with me till this point?
Yeah.
Yes. Yes, please go ahead.
Okay. So next we will explore F. Okay. So F will be added to our closed list. Right. And what will be added to our open list? Let's have a look at the elements. So B is already in the open list, so we don't need to add it. We will add E, D. C is already in the closed list, so we don't need to add it. So we will add E, D and H in that order to the open list. Okay. Clear until this point?
Yeah.
Okay. So this is the
So,
point
so,
where,
so
yeah,
I have a doubt. Why we are writing EDH? Why can't we write DEH?
because that is the order in which we are given the movegen function, right? In the movegen we were
Okay,
given
sir.
B, E, D, C, H, out of which B and C get omitted because they are either in the open or closed list. Whatever nodes remain, we have to still maintain their order. That's why.
Got it. Got it.
Okay, thanks for your question, Shiva. So this is the point where I had made the mistake, and yeah, thanks for correcting me. And this is something I think a common mistake. So this is where we choose E, okay, for exploring the next. The next node that will be explored will be E. Okay, so E will be added to our closed list. Sorry for that. So E, F, C, S, and let's see where we can go from E. From E we can go to A. A is already in the open list, so we don't need to add it. D is already in the open list, so we don't need to add it. H is already in the open list, so we don't need to add it. F is already in the closed list, so we don't need to add it. So we don't need to modify the open list at all, right? So the only thing remaining will be D, H, A and B. Okay. Next, which node will be explored?
D.
D. That's right. So let's add D to our closed list. Okay, and let's see which are the nodes that we could add. So from D we could go to F, E and A. F is already in the closed list, E is already in the closed list, A is already in the open list. So again nothing else will be added. We only have H, A and B. Okay, then the next node to be explored will be H. So we will add H to our closed list. Okay, and let's see where we can go from H. From H we can go to F, but F is already in the closed list, so no need to add that. E is already in the closed list, so no need to add that. I is something unexplored, so we will add I, we will add J, and we will add G as well. Right, so I, J, G, A and B will be our open list. Okay, next I will be explored. So let's add I to our closed list. I H D E F C S. Okay, and let's see where we can go from I. We can go to H and J, right? But H is already in the closed list and J is already in the open list, so we don't need to modify the open list, right? We will just let it be J, G, A and B. Okay, and then next J will be explored. Okay, so J, I, H, D, E, F, C, S. Okay, and let's see whether we modify our open list at J. From J we can go to H, already in the closed list, I already in the closed list, G is already in the open list, so we don't need to modify that, and then we are left with G, A and B. Now the next node that will be explored will be G, right? And G is our goal node. Now once we reach the goal node, we stop the algorithm, right? So we explore G, and the rest of the things, it will be the same. I'm not writing it again. And we have reached G, so we stop our algorithm. DFS has found the goal node, and that is our solution.
Sir, could you scroll down your screen a bit?
Sure. Is this fine?
No, the complete one. The complete list. Yeah. This is fine, sir. Thank you.
Yeah. So while you're looking at it, there was a question in the chat box that I'll try to address. Could you explain the segregation method of open and closed list? So basically, so open list is basically a list of nodes that are yet to be explored, okay, and they are put into a stack data structure, okay, and closed list is a list of nodes that have already been explored, so you keep track of these nodes so that you don't revisit those nodes, okay. And this I've used a stack data structure for a closed list as well. You may use another data structure as well, okay, but stack is more intuitive, so I prefer to use that. Yeah, so that's the segregation of open and closed list. So we have been talking about
Thank you for the explanation, sir.
thank you. So to address another question in the chat box, we have been discussing application of simple search methods like depth first search, and we've in the upcoming questions we will be seeing breadth first search as well on very simple graph networks that such as the one that is shown over here, okay. So now I hope the solution is clear. Any doubts in the solution till now?
The solution is clear, sir. Thank you.
Sir,
Okay.
here actually the close list, what we got at the last, that is the basically trace we will be actually going through, right?
Exactly. That will give
But
us, yeah.
right, okay. So here first we started from S, then we went to C, then we went to F, then we went to E, from there D,
Yes.
and then H. But H basically from D to H there is no H, so I am
Yes,
just
correct.
confused there.
Correct observation, Vikram. Thanks for pointing that out. So what the closed list tells us is the order in which we have explored nodes, not necessarily traveled from one node to another. Okay. What this tells us is when we were at S first, we explored C next, okay, then we explored F next, then we explored E next, then D, then H. There doesn't have to be a edge between D and H for us to explore that. When
So
we
would that mean means I'm I'm still not clear, means how that can be a solution. So would we be backtracking from there and then going to the goal node, because ultimate aim for us to reach the goal, right?
See, yeah, that is a very fair point, and that's where the search tree that we are trying to find in the question, that will be handy. Okay, so let me try to draw the tree for you. Just give me a moment. So initially we were at S. Okay,
Right.
from S we could go to CA or A or B, right? We chose to go to C, but A and B are still in our open list, so we will still
Right.
add that to our tree. Okay,
Mm-hmm.
from C we went to F, or as in we explored F. Okay,
Right. Right.
and then from F we could go to E, D, and H. Right, we also explored them in this order as well, right? From F
Right.
we first explored E, then D, and then H, right? We didn't find the goal node while exploring E or D, but when we were exploring H we added I and J to our open list. And G as well, which is our goal node that we want to find,
Mm-hmm.
right? And let me use a different color maybe. Right, so this is our search tree. Okay, out
Okay.
of which the explored nodes are S, C, F, E, D, H, I, and J, and then finally G is the goal node. Okay,
Okay.
so once we have drawn this search tree, we know that we explored all these different nodes that led us to G. So the path that we will follow is, we will first go from S to C. Okay, let me correspondingly mark it in the diagram as well, S to C.
Mm-hmm.
Then from C to F.
Right.
Then from F to H, because going from F to E and D did not give us the goal node, right? So we know that exploring this direction or this depth is not useful for us.
Yeah, means that means we must have actually in coding sense, or like in the actual algorithm, we must have backtracked back to F and then explored this. That is what we have done there, right? Actually,
Exactly,
we
yes.
went there and again. Okay.
Yes. So from H, from F we went to H, and then from F we can directly reach G.
Right. Okay.
Okay, so that
Good
is the,
morning.
sorry.
Someone maybe
Okay,
unmuted. Yeah.
okay, no worries.
I
Yeah,
have one doubt, sir.
okay, so if you have a doubt, please feel free to ask your question in the chat box or unmute yourself. But if you don't have a question, I would really request you to please keep yourself muted. That will maintain the decorum of the class. Yeah, so I was just saying that this is the path that we follow, and this is the search tree that we arrived at.
Okay. Okay. Thanks. I think this is clear now.
Okay,
Thank you.
thanks for your question, Vikram. So now coming to the options that we had. So our option matches with tree 4 over here, right? So let's check the answer. So tree 4 is the correct search tree that DFS will give us. Okay, I hope that was clear.
Yes, sir.
Yes, sir.
Yes, yes.
Okay,
Clear, sir.
okay, let's move on to the second question
Yes.
then, where we will find the BFS search tree, the breadth first search. Okay, and unlike depth first search, instead of using a stack, what data structure will we use?
Q.
Queue, that's right.
Okay.
Yes, we will use a queue data structure. So again, I'll give you a couple of minutes to try to find the correct tree yourself, and then we can go into the detailed solution.
Hello.
Yes, Megha, did you have a question? Okay, maybe not. If you're not able to, if the audio is not properly being conveyed, you can feel free to write your question in the chat box as well. Okay, we already have a couple of solutions in the chat box, and tree 2 and option B is in fact the correct answer. So that's great, guys. But just for the sake of completeness, let's just have a look at the solution. Okay, and it'll be intuitive, I think, now that you're already familiar with the DFS uh, search tree construction. So I'll just remove the things that we had written for DFS, and we will use open and close list again for breadth first search as well. Okay, let me erase these as well. All right, so again we will start with S. Okay, and closed will be empty as of now. Next we could go to C, A and B, right? So we will include C, A and B into the queue. Remember, this is a queue. Okay, and in queue we insert things from the rear end and things get popped out from the front end. So if this is the front end, this is the rear end, we will insert elements from this end and we will remove elements from the front end. Okay, and again the order in which the elements are inserted into the queue would be similar to the order that is given in the moveGen function. Okay, so because C is the first over here from S, C was inserted first into the queue, then A and then B, and then because C is in the front of the queue, C will be the one which is removed first and explored next. Okay, so let's add C to our closed list, and then from C we can go to F, B and S, right? B is already in the open list, so we don't need to add B. S is already in the closed list, so we don't need to add S. So F is something that we need to add to our open list. Now where will we add F? Can someone tell me?
At the tail
After
Rare
after
end.
B.
B.
Rare end.
At the
So
at the
first
end.
A, B, F.
Exactly. So all of you are correct. A, B and then F will be added over here, right? Because this is a queue. So next A will be explored, right? Because this is at the front of the queue. So A will be added over here, and then here we will have B and F, and is there something that we need to add? We have B already in the open list, E is something that we need to add, D is something that we need to add, S is already in the closed list, so we don't need to add that. So this will be E and D, right? Maybe I'll make this diagram a bit bigger so that you can see it along with. Okay, Is that better? Can you see it clearly now?
Yeah.
Okay. Okay. So next we will explore B. So we will have B, A, C, S. And here we will have F, E, D. And then from B we could go to A, but A is already in the closed list. C is already in the closed list. F is already in the open list. S is already in the closed list. No need to modify the open list. This is what it will be. Next, F will be explored. Let's add F to our closed list. And our open list will be E and D, and let's see if we need to add something else. From F we could go to
H.
That's right, H is the only thing that will be added. Okay, so this is our open list. Next, E will be explored. So we will add E, F. Okay, I'm not writing the whole thing. It will be the same thing as the above, right? And then D and H. And when we are at D, we don't need to add anything because these are already either in the open or closed list, so it will remain same. Next we will explore D, so it will be D, E, F, and so on, same as above. And will we need to add something?
No, sir.
No, right? We don't need to add anything.
So we are left with H only.
Yes, we are left with H only in the open list, so we'll add H to the closed list. Okay, this will be the same as above. And in the open list, let's see if we can add something. F we don't need to add, E we don't need to add. We need to add I, J, and G in that order. I, J, and G. Okay, next I will be explored, and you can verify this yourself that nothing else will be added, right? Because from I we can go to H and J, both are already covered. So I will be added to the closed list. We will remain with J and G. Next we will explore J. Again, same as above, the rest of the closed list. And will we add something else? H, I, G, nothing else will be added. So we will be left with G in the open list, and G is the goal node. So we know that we have reached the goal node, and we will terminate the search algorithm. And this is the breadth first search. Okay, so now let's try to construct the tree. Okay, so we were at S first. We could have gone to C, A, or B. Again, sorry for my horrible handwriting, but bear with me. Okay, so from C we could have gone to F, right? What is the order in which we added these elements? From S, C, A, B, then F, and then E. Okay, but when was E added?
D, EDH.
Yes, I'm just trying to see where to add E. Will it be a child of C or A is what I'm trying to find. So when we were at C, when we were exploring C, we added A and B. Sorry, when we were exploring S, we added C, A, and B, right? Now when we were exploring A, we added Sorry, when we were exploring C, we added F. Okay, so F is a child of C. When we were exploring A, we added E and D. So E and D will be children of A. Okay, is this point clear? Any confusion why we added E and D below A and not C?
Okay for me.
Okay. So Shreyas, I'll come to your question. I'll just quickly complete the search tree. Okay, so now similarly we will keep adding elements to our search tree, right? From F we explored H, from H we explored I, J, and then finally G, and this is where we stopped. And if I use a different color to mark our path, we were at S. From S we will go to C, from C we will go to F, from F we will go to H, and from H we will go to G. So it happens that both DFS and BFS have found the same path, but that may not always be the case. Okay, the search tree that you notice is different between BFS and DFS. So going back to our options, we see that this tree that we just made is same as tree 2. So tree 2 is the correct option. And coming to your question, Shreyas, you asked that DFS uses stack and BFS uses queue, but their searching method is same. Not really. Okay, so as the name suggests, depth first search will go into the depth and explore a particular depth. If it can't find the goal node in that depth, it will retrace itself, go back to the point where it had bifurcated, and then explore another depth. Okay, whereas breadth first search will explore its whole neighborhood before going into depths. Okay, if I have to explain this diagrammatically, it will be something like this. So imagine this is your start node. Okay, this is your goal node. Okay, and there are several nodes in between. Okay, these are connected via different edges. I'm not drawing the whole diagram, but these are all connected via some graph. Okay, what depth first search will do is it will decide on a certain depth or a certain direction, and it will explore that. Let's say it decided to explore this, then this, then this, then this, then this, then this, and finally it reached goal node. So it followed a certain depth and went into the deep end, and then it reached the goal node. In case it is not able to reach the goal node, let's say there is no connection from here to goal node, it will retrace. Okay, it will go back and see that, okay, from here I could have gone in this direction. So now it will start exploring this depth. From here it will go to here, to here, to here, let's say to here, and then finally to here. So it will always explore a certain direction and a certain depth. This is depth first search. What breadth first search does is, let's say this is your start node, this is your goal node. This will start exploring its neighborhood. So it will explore all the nodes around it first. Okay, so it will explore these, then it will go to its next neighborhood, all the nodes in this neighborhood, like this. It will keep on exploring until it reaches the goal node. That is the difference in the logic between depth first search and breadth first search. Does that help?
Yes, sir.
Okay, that's great then. DFS is more efficient or BFS is more efficient, I'll let you explore that. Okay, so a question that I want you to think about is, does depth first search or breadth first search, does it always give you a solution? Can it be the case that one of these will get stuck at some point and not be able to go back to reach the goal node at all? Okay, think about this, and we can discuss it in the next live session also if you don't find an answer. But think about this question. Okay, that will give you an answer to which method could be called more efficient. It is also quite problem specific. In some cases, in some problems, DFS is more efficient. In other problems, breadth first search is more efficient. Okay, so there's no unique answer to that question. Okay, coming back to the questions that we had. Okay, so we are done with the previous graph that was given to us. Now we have a new graph. Okay, and this also talks about a directionality. Okay, so one of your friends had mentioned that directionality may or may not be given, right? And if you notice over here, there is a direction, there's an arrow from F to A, which means that we can go from F to A but not from A back to F, and that is also reflected in the moveGen function, right? From A you can go to C and S, which does not have any direction, which means you can go from A to S and S to A, and A to C and C to A, but you cannot go from A to F. Whereas when you are at F, you can go to A as well as E. Okay, so just pointing that out because that was a question that was raised earlier. Again, I'll let this graph and the moveGen function be here for a minute so that you can familiarize yourself with it, and then we will move on to the questions based on this particular graph. Yeah, so one of your friends says, Shiva has answered that BFS is complete. DFS may get stuck in an infinite path, and yeah, I would encourage everyone to try to explore that yourself and maybe try to find out a problem where DFS will go into an infinite path. Okay, that will help you develop an intuition as well if you don't already have it. Okay, I hope the graph is now familiar. Let's move on to the question based on this graph. Okay, so question asks us, at the instance when BFS, breadth first search, finds the goal node, what is the closed list? What are the contents of the closed list is what you have to answer. To find that, we have to essentially solve the breadth first search on this particular graph that is given to us, right? So I'll let you try to solve this using BFS yourself first. Okay, so I'll let it be here for a couple of minutes and then we can have a look at the solution, but feel free to put your answers in the chat box in the meantime if you find it. Okay. Okay, so we already have a couple of answers in the chat box, and most of you are in fact correct. So congratulations on that. Let's have a look at the solution and see how we arrive at that solution. Okay. Yeah, please keep yourself muted if you don't have a question. Thanks. Okay, so let's try to solve it using the method that we just saw. Okay, again this is a BFS, so we will be using a queue. Okay, so initially we will have S and closed will be empty, right? Next we will add S to our closed list, and the elements that we could go to from S are A and B, so we will add A and B, right? And then we will explore A, right? And then the open list will be B, and then from A we could go to C, right? And S is already in the closed list, so don't need to add it, so BC, right? Next we will explore B, so BAS will be our closed list, and then our open list would be C, and then let's see if we can add something else. So we don't need to add C. D is the new element that we need to add. S is something we don't need to add. So CD will be our open list. Okay. Next C will be explored, so CBAS will be our closed list, and then the open list would be D, and then G would be added. Right? C and B we don't need to add. Next D will be explored, so DCBAS, let me correct that.
E is missing, right?
Oh, did we miss E?
Yeah, E. For C, we have EADB, right? E is missing.
Right, correctly pointed out. Thanks for that, and sorry for excluding that. So we explored C, so it will be CBAS, and then this will be D, and then from C we could go to E and D, so that will be added, right? Oh, D is already there, we don't need to add D. So E will be added, we don't need to add A, we don't need to add D, we don't need to add B. Yeah, this is what was missing, right?
Sir, you can repeat once more, sir.
Sure. Do you want, from which point do you have the confusion?
Open A and B, close yes, sir.
Okay, sure. So we are at this point. Okay, we will explore A next, right? Because it's at the front of the queue. So A will be added to our closed list. From A we could go to C or S. S is already in our closed list, so we don't need to add that to our open list. C is something that we have not seen till this point, so we will add C to our open list, but from the back, because this is a queue. Okay, that's how we have B and C over here in the open list now, and then B will be explored because this is at the front of the queue. Okay, so B will get added to the closed list, BAS, and similarly when we explore B we will add D to our open list. C and S don't need to be added because C is already part of the open list, S is already part of the closed list. So that gives us C and D, right? And then next we explore C. C gets added to our closed list, so CBAS. And then when we explore C, we add E to the open list. A doesn't need to be added because it's in the closed list. T doesn't need to be added because it's in the open list. B doesn't need to be added because it's in the closed list. Okay, so that's how we arrived at D comma E. Okay, next D will be explored. So D, C, B, A, S. Right, and then our open list will be E and then G. Right, because from D from D we could go to G, C and B. C is already in the closed list, so don't need to add. B is in the closed list, so don't need to add. G is already is the only thing remaining, so we add G to our open list. But from the back, because E is in the front now, we will explore E next. So E, C, B, E, D, C, B, A, S. And then G is the only thing remaining in the open list, and we have reached the goal node, and so we stop. Okay, so at the moment when goal node is reached, the content of the closed list are E, D, C, B, A, S. This is what we wanted and what the question asked us. At the instance when BFS finds G, what is the closed list? It's E, D, C, B, A, S. Okay, so I see many of you have already mentioned GED and then the rest of it. We don't need to mention G because at that moment closed list is not having G. At the moment when G is in the open list, that's when you encounter that okay, G is the one that is to be explored next. That's when you stop.
Sir, I need to clarify one thing, sir.
Mm-hmm.
Only after the completion of a single bracket of nodes, then we can go to the open and the closed segregation.
What do you mean by bracket of nodes?
If we take A and B,
Mm-hmm.
only after the completion of the segregation of open and closed over there, thereafter we can go to the C and S.
Not necessarily. It just depends on the order in which you are going to explore the nodes, right? This is a queue. That's why when we included this into our open list, A and B got pushed to the front, right? And then when when A was explored, C was the element that was supposed to be added. We added it to the back. If let's say hypothetically if we had AEB, right, then the open list would be AEB. Is that your question? Am I answering it correctly or was it something else?
Yeah, that's right, sir.
Okay.
And after E, why we can't add F? Because F is the first element in the E. Mujan.
From A, we can go to only C and S, right? Look at the margin. So
Yes.
from A, we can't go to F. That's why we are not adding F when we explore A.
No. I'm talking about exploring of E.
Exploring of E. Okay.
Yes.
So when we explore
F is the first element.
Okay, let me go back. Yeah. I mean, we will add F to open list, but it will get added at the back, right? So when we explore E, the element that are left is F, right? C and G don't need to be added, so it will actually be G comma F, the open list. But
No.
So
while we exploring E, we wrote G. There we have to write F comma G, I think so.
G comma F.
If I'm not wrong. No, before step.
This one.
Yes.
Here we are exploring D, not E.
Oh. Okay, got it.
Right? Okay.
Got it. Thank you.
Yeah. But good point. Thanks for asking that, Shiva.
No, sir, he meant after D, you're exploring E comma G, no?
Yeah, so once we explored D, right, we added D to our closed list. This is the open list that we are left with. Okay, so we will now decide which node to explore based on this open list. And since E is at the front, we will explore E, and then E will be added to the closed list. And when we explore E, F will get added to the open list. So this will be the open list when the program terminates. Okay, because at this point we know that the next node to be explored is G, so we don't really need to go any further. We know that we have reached the goal node. Does that answer your question? Okay, great. Okay, then I hope this question was clear. Let's move on to, okay, this is something that we just answered. At the instance when BFS finds G, the open list is G comma F. Right? I hope there are no doubts there. If there are, please feel free to let me know.
No doubt, sir. You can move to the next one.
Okay, great. So now we are asked the same. We are asked questions on the same graph, but now we have to apply DFS. Okay, so again I'll let you try to solve using DFS, and then we'll have a look at the solution. So I see a lot of you have already answered the question, and FECAS is actually the correct answer, but there are some doubts about it as well. So let's go over the solution. Okay. So okay, so now we will solve using DFS. So we will use a stack. okay, not a Q. So again we are at S, right? S will be moved to the closed list and the open list will be A comma B, right? Next, the node that will be explored will be A, right? So we'll add A to our closed list. But when we explore A, we need to add C, right? Because C is in the C is still unexplored. We will add C to the front because this is a stack. So the open list will be C comma B, not B comma C like it was in case of BFS. Okay. Now next C will be explored because it is at the front. It is at the front of the open list. So this will be CAS, right? And when we explore C, E needs to be added, A doesn't need to be added, D needs to be added, and B doesn't need to be added. So we will have E, D, and B in the open list. Okay. Next, E will be explored. So we will have E, C, A, S. When E will be explored, we need to add F. C will not be added because it's already in the closed list, and then G will be added, right? So we will add F, comma G, comma D, comma B, right? This will be our open list. Next, F will be explored. So F, E, C, A, S. And when we are at F, we don't need to add anything else because A is already in the closed list and E is already in the closed list as well. So our open list at this point is G comma D comma B. And we see that the next node to be explored is the goal node, so we don't need to go any further. We stop the algorithm and we say that we have reached the goal node using DFS, and at this point this is our closed list, this is our open list. So does that clarify, Naren? How do we get F in the closed list?
Yes, sir. Yes, sir. I joined late. I did not see the move gen. I
Okay.
took alphabetical order as the move gen. So after C, it goes to D and G.
Yes. So that's a valid point. So again, I'd like to emphasize that over here in this specific problem, we are assuming that the order that is given to us in MoveGen is the one that will be followed for insertions or deletions, right? Please make sure that when you solve the assignments or your exam, you look carefully whether you have explicitly been told to use any other order. For example, if the question explicitly mentions that you have to use alphabetical order, please follow that. Okay. So just be careful when you try to solve these questions because sometimes these trivial restrictions on the question is what lead to different answers, and that can eventually lead to reduction in the marks, right? So just be careful around it. So I hope the algorithm was clear. Any doubts there?
Sir, but while close this, we didn't add F code.
Sorry, Dhruv, can you
I mean
come
for
again?
D.
Can you come again, Dhruv? Sorry, I couldn't get you.
Sir, in close list, why we didn't add D?
In D, because we didn't explore D yet. So we always explore the element that is at the top of the stack, right? And this is the way the stack is, right? This is the top of the stack. Okay, so here A was at the top, so we explored A. So A got added to the closed list over here, and then we added C again to the top. Next we explored C. C gets added to the closed list, and then E and D get added to the top. E gets explored and added to the closed list, and then F gets added to the top. F and G get added to the top. F gets explored and gets added to the closed list, and then G is remaining at the top. So we didn't even reach D. That's why D was not included in the closed list.
Okay, sir. Okay.
Okay.
Yes, sir.
Okay. Thanks for the questions. Yeah. Was there another question? Okay, maybe not. So coming back to our list of questions, so this asked us at the instance when DFS finds G, what is the closed list? And I think most of you already answered. It is FECAS, which we arrived at. And so I hope there's no doubt there. Next, we have question 6, which asks us at the instance when DFS finds G, what is the open list, right? And we saw that the open list is
G, D,
GDP.
Exactly. Yeah, you are correct. So the open list is G, D, and B, right? So that brings me to an end of the questions I had for today. So I just wanted to give a flavor of DFS and BFS via a small graph and a slightly bigger graph. There are other methods that have been discussed in the lecture videos. I would encourage you to try to look into those as well. See how they are nothing but small modifications on DFS or BFS. Okay. Try to understand those and see if you can intuitively develop algorithms for those as well, or develop or try to solve these two simple graphs itself using those other methods as well. If you have any queries, please feel free to let me know through the discussion forum or now, so that we can discuss it in the next live session. Please draw the tree for the last one. Okay, let's try to draw the tree for the last one.
Sir, please understand the question number 1 once more.
Question 1.
Yeah.
Okay, let's try to draw the tree for this first, and then let's see. Let's go back to let's revisit question 1 briefly.
Okay.
Sorry to interrupt. This is the last question, right? Those who have understood can leave the session.
Yeah. So this is the last question. We won't be discussing anything new. If you don't have any doubts, you can feel free to leave.
Okay, sir. Thank you.
Thanks for attending. Okay, so we start with S. Okay, from when we explored S, we added A and B to our open list. Okay, next we explored A, and when we explored A, we added C to our open list. Next we explored C, and when we explored C, we added E and D to our open list. Okay, next we explored E, and we added F and G to our open list. Okay, so this is what the search tree will look like. Does this answer your query, Ravi? Okay, great. Thanks for the kind words, Kashif, and Naren as well. So I'll briefly revisit the first question because it was requested. I won't go into the full details, but I'll just give an intuition. So essentially what we did over here was we had a slightly bigger graph, okay, and we tried to solve it using depth first search. Okay, so when we use depth first search, right, we start with S, okay, and then from S we can go to C or A or B. Okay, so we add that to our search tree. Now C is at the front of the stack, so C will get popped out and explored next, right? And when we explore C, you add F to the open list because B and S do not need to be added. B is already part of the open list and S is already part of the closed list. So F will be added to the open list and it will be added to the front because it's a stack, right? So F will be explored next, right? And when F will be explored, we will add E, D and H to the open list. We will explore E, nothing will be added to the open list. D, nothing will be added. When we explore H, I and J and G will be added. And then we will explore I, nothing will be added to the open list. J, again nothing will be added to the open list. And finally we will arrive at G node. Okay, that is the basic tree structure. That is what we discussed in question 1. If you want to look at the open and the closed list, I think I have a Jamboard from a previous session and you can try to explore it. Okay, so this is the one for the old one, the smaller graph. One of these would be probably the open and closed list for DFS or PFS. Okay, so you can try to first try to solve it yourself and then you can verify it with this particular sequence of steps. Okay, so does
Okay,
that
sir.
answer your question, Yachna?
No, I understand you.
Okay, great. So there's a question in the chat. It's your first class. So in the previous live session, if you're talking about that, we didn't really discuss anything too much in detail. That was just an overview of different kinds of things that you will explore later on in the course, and so the recording for that is also available, so you can explore that at your leisure. If you have anything specific from the previous few, this week 1 or week 0 that you want to discuss, you can let me know and we can have a look at that. Otherwise, I would just say that revisit the previous lecture recording, and I think it's now available on Swayam, so I just checked before the session. So those of you who were asking when will it be available, now it will be available to you instantly. So as soon as this live session ends, I will upload the recording and then I will update the Google Sheet and you can have access to it by tonight. So Dhruv, the questions that we are discussing in the live session, those are similar questions to what you will be asked in the assignments as well as the final exam, right? So you can expect similar questions, not exactly same, but something along similar lines. Where can we access the Google Meet session? Let me just show that to you. So this is the Swayam portal, okay? And over here you have each week's video lectures and the assignments, right? Week 1, week 2, so on and so forth. So here a new section has been added called problem solving session. If you go to the first link over here, this will lead you to, if you click on it, it will lead you to this particular web page. It will ask you to click here. When you click this link, this will lead you to this Google Sheet, okay? And here each week's recordings will be updated, okay? So for example, you have week 1's recording link over here. Similarly, by tonight I will add week 2's link and we will keep adding the 12 weeks links over here, okay? So this is how you can access it. So Rajat, thanks for your question and your curiosity, but I don't think this is the right platform for me to discuss my PhD thesis. You can feel free to explore my webpage. If you just type my name, I think you should find it, and if you want to discuss something, we can connect offline as well, okay? Also, don't worry about anything. If you have missed the live session, Chandrakanta, the recordings are available online. You can watch them anytime.
So, on a small request, could you just go through the second question? There's a little bit of doubt over there, sir.
Okay, second question was the same thing, just BFS applied to the bigger graph. What was your specific doubt there? Yeah, this is it.
Yes, sir. So over there, in the open and closed segregation methods, we have suddenly cut at H.
Mm-hmm. Not suddenly. I think when we explored F, right? when we
Yes, sir.
explored F, at that point, H would have been added to the open list, or maybe before that.
And we just got the closed list. After that, we went to the new open list.
No, so closed list and open list are maintained simultaneously. It's not like once one gets filled up, then the other gets filled up, and so on and so forth. So the moment you are, let's say, in your open list at a certain point of time, you have A and B, okay, and in your closed list you have only S. Now, when you are exploring node A, at the same time, simultaneously, A will be added to the closed list, and some of the elements that were supposed to be added to the open list because we explored A, that will be added to the open list. So open list and closed list will be updated simultaneously. Does that answer your question, or was it something different?
I get it now, so thank you.
Okay, thanks for your question. So, is there anything else that any of you would like to discuss?
Yeah, I like to have a word with you. Regarding assignments, already it is submitted. How do we know that it is submitted like that? Why means I'm getting a reminder mail that the assignment date, kindly submit the assignment like that, even though I have submitted.
That might be a general reminder.
Hema.
Hema, yeah, thanks.
Okay, so somewhere I can see that assignment 1 is submitted, 2 is submitted like that anywhere?
Yes. So if you go to your quiz, here you will, if you have not submitted, you will see assignment not submitted. If you have submitted it, you will see the timestamp at which you have submitted, or some indicator that you have submitted it. Okay.
Okay,
And
thank you.
the email is, I think, a general email, so don't worry about it. As long you have submitted and it is acknowledging over here, somewhere over here on this web page, you don't need to worry about it.
Okay.
Sir, how to get the score? Is it will show on the portal itself?
So once the due date has passed, then you will once the due date has passed, you will be seeing the correct answer at the bottom of each question. So for example, if you selected a certain option over here, let's say one of the options, if your answer is correct, it will be reflecting in green. If your answer is wrong, it will be reflecting in red. And then you can just calculate based on how many of you got correct the final score or something like that. Okay.
Thank you, sir.
To answer some other questions in the chat box, Varun, I see your query. I understand that some people might be preferring Hindi, but the thing is, there might be other people as well who might prefer other languages. I don't know all languages, right? So we have people from different parts of India. The common language that we have in the course is English, so that's why I'm sticking with English. If you have any specific query that you want me to address, you can stay back and I can try to help you in Hindi. But again, I don't know the different languages that so many of you speak, so that's why I prefer to keep the sessions in English. Yeah, that's about it. Ambrish, DFS, I think we have gone over DFS ample number of times. So if you have any specific query about DFS that you want to be clarified, let me know. Otherwise, you can just revisit the lecture recording. It will be uploaded soon by tonight. You can't join the session at 6 p.m.
Yes, it's me only, Chandrakanta, sir, because my job profile does not allow. Because while returning home, it takes 7 o'clock. Today was holiday, so I joined the session. If there will be query, how to interact that, sir.
I see. I would say that the best medium is the discussion forum. Okay, I would again point you to where that is. So there is this Q&A tab over here, right, on Swayam.
Okay, sir. Okay.
If you click on it, this will lead you to a Google group. And there you see many people have already asked your questions. If you have any specific questions for me, please in your subject, when you write this email, when you add this new conversation, you just
Okay, sir.
mention live session so that I can identify it easily. I will try to address that. If you
Students
have,
from the my recent group where to the I have to compose new mail, isn't it?
yes, you have to compose a new mail. Yeah.
That is a new conversation, isn't it?
Yes.
Okay, sir. Thank you so much, sir.
Okay, no worries. If you have a general query, you can also feel free to not include live session. In that case, it will be answered by Bhaskaran sir. He is the main TLE of the course. You can already see that he has answered some questions over here, right? So he will be addressing some of the general questions as well. Anything related to the live session, I am happy to address.
Thank you so much, sir.
No worries. Please explain closed list again. So closed list is nothing but the list of nodes that we have already explored. Okay, and how we arrive at that, you can revisit the lecture recordings. Okay. Assessment questions. Ambrish, which assessment question? You mean the assignment? Assignment you can find in the Swayam portal. Okay, you won't get a separate mail. Here on the right side on the Swayam portal, you have different weeks, right? For each week, you have this quiz link over here. That's how you have to go to the assignment and then answer it. Okay, once you have filled in the answers, click on this submit button. That's how your answers will get registered. मेल नहीं आया एज इन सबमिशन के बाद मेल नहीं आया? So usually submission के बाद मेल नहीं आता है. You will just be notified that you have submitted on the web page itself. Okay. Don't worry अगर मेल नहीं आया. As long as you have submitted the answers and you have an acknowledgement on the portal that you have submitted, it will be considered. Okay, just make sure that you click on the submit answers button. Okay, that is important. Okay, any other thing that you would like to discuss? If not, maybe we can close the session for today. अम्बरीश, असाइनमेंट क्वेश्चन का अलग से मेल नहीं आएगा. यू हैव टू गो टू द स्वयं पोर्टल एंड देन आंसर द क्वेश्चंस ओवर देयर. Okay, maybe it might have, you will receive a general email that assignment for week 1 released, something like that. ऐसा कुछ आ सकता है. Just check if that went to your spam folder. Okay, but regularly keep checking Swayam, your course web page on Swayam. Okay, that's how you have to be updated about the different developments. Sometimes mails don't reach our inbox, so just be careful. Okay, if there's nothing else, maybe we can close the session for today. Okay, thanks all for attending, and let's meet next Tuesday again.
Thank you.
Thanks for attending.